from Benin. You're welcome, Jennifer. And Bonnie will moderate the session. Yeah. Okay, can you share again, Jennifer, your screen, your presentation, and then we'll start the talk. I think she's logged out. Can we have Dr. Sharon? Sharon, can you start presenting? And then we'll have Jennifer next. I think she's logged out.
Okay, thank you. Good afternoon. I can do the presentation.
Okay, please. Are you able to share your screen now? Your presentation, Sharon?
Yes, I'm trying to share the screen.
Okay.
I can see the button is green for me.
Yeah. Are you able to project your PowerPoint?
Yes, that's what I'm loading.
Okay, sure. Great. Yeah.
Are you able to see my screen?
Yes, yes, we are able to see it.
Thank you. So,
Yeah, welcome.
thank you. So I'm Dr. Sharon Kiprotich from Murang'a University of Technology, Kenya. I'm going to do my presentation on the research project that we are currently undertaking, supported by DSA. And the title of the project is Preparation and Investigation of Multifunctional Materials Based on Transparent Conducting Oxides for Possible Solar Cell Application. So currently I am the PI for this research. In my presentation, I will do a little bit of introduction, talk about the materials under investigation and project milestones, research outputs, and then the summary and conclusion. So, do full screen. So in the introduction, we are dealing with nanotechnology. So we are synthesizing nanomaterials for nanotechnology. So what is this nanotechnology that we are trying to research on? And we are actually looking at this being the study and application of matter in a near atomic scale. And the materials that we are looking at are actually at nanoscale. The materials that we are synthesizing in the laboratories come out at nanometer scale. And the applications of these nanomaterials are mainly on electronics, medicine, biomaterials, and the energy solar cells. The energy solar cells is where our concentration is, and we are synthesizing materials for basically the solar cell applications. And we have types of nanomaterials that can be synthesized for this application. We have the one-dimensional nanomaterials which come in terms of nanotubes, nanofibers, and the nanowires. You have the two-dimensional nanomaterials also, in terms of nanoflex, nanoplatelet, nanosheets. And we have the 3D nanomaterials, which are now the nanoparticles, the nanotubes or the nanorods, and the bulk powders. So in our research, we are trying to concentrate and see if we can find the nanomaterials, the nanorods, and those will be used in the application of the solar cell that we are working on. So in this solar cell, the nano-based solar cell, for example, a material like zinc oxide nanoparticles, which is in this diagram, you can see the nanoparticles. Sometimes you can find them in a spherical shape. So these nanoparticles are used in the solar cell to try to improve the efficiency of the solar cell. And if we get the nanorods mainly we obtain when we deposit the thin films. When we deposit the thin films on a glass substrate, we can get the nanorods. Most of the time, for us to get the nanorods, we have to have a seeded substrate. And the seeded substrate has to be nanoparticles which have been optimized. So that using the seeded substrate, which can be any compound under investigation, either zinc oxide nanoparticles, can be titanium dioxide nanoparticles, can be cadmium oxide nanoparticles, to be the seed for the glass substrate. And then now on top of the seeded glass substrate, we now grow the nanorods, which are going to be used in the fabrication of the solar cell. So the nanomaterials which we are currently researching on, we have three main compounds. We have titanium dioxide nanoparticles, which after optimizing the nanoparticles, we deposit the thin films. Now, for us to fabricate solar cell, we use a thin film. So we start our project all the way from synthesizing the nanoparticles, which are the titanium dioxide. Then after getting the optimized, we deposit on a thin film to grow the nanorods, which are now used in the application of the solar cell. We also have zinc oxide. The same case, we optimize the nanoparticles, grow the nanorods on the thin film. And as I said earlier, this thin film, we form a seed first before growing the nanorods, and these seeds must be an optimized nanoparticles on them. The other compound is cadmium oxide nanoparticles. So we optimize the nanoparticles in the synthesis, and then we use it in the thin film deposition, which we obtain a thin film, which can be used in the solar cell. The synthesis methods that we are currently employing, one, we have the sol gel technique. And this sol gel technique, mostly we are applying it on oxide nanoparticles. And in this case, it is applying to all our compounds. We have the zinc oxide, TiO2, and the cadmium oxide. We also have the chemical bath deposition technique, which we are currently using to deposit the thin film, especially at the trial phase. We try with the chemical bath deposition. Our project was also looking at using the sputtering technique in the thin film deposition, but at the earlier stage of the research, when we are trying out the thin film, the chemical bath deposition technique. Then we also have the precipitation technique, also for optimizing these oxide nanoparticles. So the precipitation techniques allow us to optimize the nanoparticles which we are preparing, which are then going to be used in thin film deposition to obtain a thin film which can be used in solar cell fabrication. When you look at the project milestones, in the project milestones are broken into phases. One, from the time we receive the funds. First of all, I want to thank the DSA for this chance that they have given us. We received the funds and we were excited. We embarked into the purchase of chemicals, separators, and synthesis and characterization of these oxide nanoparticles, which we are looking forward in actually using them in fabricating the solar cell. Now, the three nanoparticles compounds that we are synthesizing, we are using the sol gel as I've indicated, and also the CBD, the chemical bath deposition technique, to optimize the growth parameters before finally
go around or milk in addition to the talking. All you need is just water and you are good to go.
Sorry, am I heard?
No, we can hear you. Sorry for the interruption.
Okay. Yeah. Thank you. So I was saying we have the three transparent conducting oxides, which are synthesized using the sol gel, optimized using the precipitation, and we try the deposition of the thin film using the CBD, which is the chemical bath deposition technique. The next project milestone is on the purchase of chemicals and apparatus. And I want to say that we did purchase chemicals and apparatus. This material science is actually the first time that we are rolling out here in Murang'a University of Technology. And having such a fund was like a seed fund for us to start off the projects in nanomaterials and also material science at large. And most of the materials that we purchase, they are actually acting like a seed for our laboratory. It is the first time that we are receiving this, and it is also the first time that we are rolling out material science in our laboratories. So we are really grateful that we managed to purchase these chemicals. A few of these chemicals, we were able to source them here in the country, Kenya, but most of them, like the dopants, the gallium nitrate, we have other dopants, selenium, gallium, cadmium nitrate, cadmium acetate, the analytical grade. We were not able to find them here in Kenya, and therefore we had to source them outside the country. And some of them had to take quite some time before they were delivered to us. So, but we are grateful that all were able to arrive on time. The apparatus, we were able to find them in Kenya, apart from a few. Actually, one of them, like the pH meters, the beakers, the Petri dishes, were able to find them in Kenya, so it wasn't a difficult part. This temperature controller, the temperature controller is the equipment which actually took very long time for us to achieve or to get it. When we ordered it, it took almost 2 months to arrive, but we want to say that the hot plates that we have in the lab were able to help us to run the experiments, to do the synthesis, but the part that we were not able to do was to be able to control the temperature as one of the growth parameters. So in our previous research, the synthesis that we were doing, we were only using one fixed growth temperature, because adjusting the temperature was going to vary a lot of things, and we may not be able to identify which growth temperature was that. But with this temperature controller, it has done us great, because we can actually set a temperature, and that temperature, if we want to synthesize a material at, for example, 30 degrees. Here, this temperature controller can limit the temperature for that precursor solution at 30 degrees. And this equipment is doing us a lot. We have used it since it arrived in the towards the end of the month of July. And since that time, we are able to try and do what we had not done with this equipment. The plate is a stainless steel plate for this, and it cannot rust. It is something that can last for long. We don't anticipate its failure anytime soon, because this is a good equipment which can be used across many projects along material science. In synthesis and characterization is still on the project milestones. We have managed to optimize the nanoparticles. Remember, in this research, we first of all grow the nanoparticles, and then after growing the nanoparticles, we deposit them in a thin film to form a thin film which can be used in fabrication of the solar cell. So optimizing TiO2, for example, requires that you optimize the concentration. If you are using a dopant, you also optimize the dopant concentration. We also have the combustion temperature. That is the temperature as it ignites until when it is annealed. We optimize all those parameters. And for this case, we realized that for TiO2, the titanium dioxide, at lower growth temperature and at higher growth temperatures, there were two phases. These two phases, we were able to identify the phase that is fit for use in the solar cell applications. Same case for zinc oxide nanoparticles. We have managed to optimize zinc oxide nanoparticles and the thin films, mainly using the chemical bath deposition technique. The main areas of this research, especially for each one of them, what we are trying to optimize when we are talking of optimizing the TiO2 or zinc oxide or the cadmium oxide. For the first one, we are doing the synthesis and characterization of titanium dioxide, and we were concentrating on two dopants, that is the zinc dopant, iron dopant, and co-doping using the two, and trying to find out which of these parameters, growth parameters, will give us the best result for thin film deposition. Besides that, we have the zinc oxide, where we were doping with aluminum and gallium. So the two, we are co-doping the zinc oxide. Now that previous researchers had shown that they had optimized the doping concentrations for aluminum and gallium. So we needed to find out, after getting this co-doped zinc oxide, what are the effects of pH, the annealing temperature, stirring speed, in trying to find out these material properties in optimizing the properties which will be best for the thin film deposition. And then for cadmium oxide, we were looking at this cadmium oxide and the dopants, which are the tin. The dopant which we were using was a tin dopant. And in this case, we are looking at the effect of reaction time, pH, because most of these growth parameters really affect the material properties of the materials that come out after, and especially if we are to improve the efficiency of the solar cell. Now, this research is mainly carried out by three Master of Science in Physics students, and these students have just taken a sample of their photos when they are busy in the laboratory. The first student is called Mr. Simon Waweru. Mr. Simon Waweru is the one carrying out research on titanium dioxide. Mr. Boniface Gachanja is an MSc in Physics student research on cadmium oxide, while Cornelius Betts is carrying out the research on zinc oxide. Now, these are some of the things that they do in the lab as they adjust the pH, the parameters, the apparatus they use. All of these apparatus are the apparatus which we managed to obtain through this research fund. And that is where we are acknowledging and appreciating. They were able to carry out their research courtesy of DSA. We have the furnace in our laboratory where they do the annealing. Annealing is where they try to improve the properties of the material. They also use it for combustion method. They also use it, since we are making sol gel technique. After getting the gel, this gel is taken to the furnace, and the furnace will complete the remaining reaction where you'll get your powder. Now we have the analytical balance, the oven. So drying of the samples is done at the oven. Period of time depending on the methodology of is basically what they've been doing, and the samples that they obtain from the furnace in the crucibles. Even these crucibles we managed to obtain from this research fund. After they get their samples from the furnace, they are able to grind them to get fine powder. This fine powder will therefore be used for further analysis, where you can identify their structural properties, their optical properties, their morphology, using different analytical techniques. A sample of an XRD data, we have an XRD data, which we call it an XRD pattern for titanium dioxide. And this one is when they were studying the effects of the furnace temperature. When they take to the furnace is able to work within a range of 200 degrees Celsius to 1200 degrees Celsius. So they were trying to find the optimum temperature which can be used to synthesize or be able to combust this TiO2 in the furnace. This other XRD pattern, we were trying to also analyze this TiO2 with different zinc concentrations. You can also, they also did analysis with different iron concentration. And then now co-doping with zinc and iron, you are able to see that the peaks of this XRD are getting enhanced and they are getting more clearer. So these are the studies which now they are able to use the data, the XRD pattern data, to find out the size of these crystal sizes, the sizes of the lattice parameters. They can also use it to find if there are stresses or strain on the material and to what extent is the material strained. If it is strained, of course, we'll be able to find from each of these samples, we are able to find a sample that has lesser strain or stress, and that will be towards optimization of that parameter. We have the FTIR spectra. This one is also used to identify the structure, but mainly to give us the compounds that are available in that material that they were able to synthesize. So from this, you can have an idea whether they actually synthesize the compound required, And to what purity? Are there any other precursor materials remaining in the compound, or we have the pure compound with us? So series of FTIR spectra. So just to mention is that this FTIR and XRD, the XRD, which is the X-ray diffractometer, FTIR is Fourier transform infrared spectroscopy. These two equipment are available here at Murang'a University of Technology. So when the students do their synthesis in the lab, once they get their dry samples, they are able to analyze in the analytical lab here at Murang'a University. They do not have to travel anywhere to get the data for FTIR and the XRD. So in my summary and conclusion, we want to say that all the expected basic chemicals and apparatus, we were able to purchase them. We managed to synthesize the nanoparticles for the three compounds, that is the TiO2, zinc oxide, and cadmium oxide. And we did a bit of thin film deposition using the chemical bath deposition and the sol gel techniques. We have managed to do characterization of the particles using the XRD and the FTIR, which are available at our university. Optimization of deposition parameters, we are saying they're still in progress, because for thin film, you cannot only use the CBD to optimize or the sol gel. We are planning to also use the sputtering technique, which we are expecting to optimize and get a good thin film out of using the three compounds that we have managed to synthesize in our labs. Another thing which is pending is further characterization of what we have already obtained in the samples. For example, we still have UV-Vis analysis, that is ultraviolet visible spectroscopy. This will help us to identify the electronic properties of the material. We also have the photoluminescence spectroscopy, which will help us to identify the emissions and the absorption capability of our material. We'll also need to find out the morphology of our material using SEM, that is scanning electron microscope, and high resolution TEM, that is high resolution transmission electron microscope. This will identify the morphology, whether we have the spherical nanoparticles or we have the nanorods. These two equipment will enable us to be able to see, and it will also help us to know how crystalline our material is, because since we are targeting to improve the efficiency of this material, then the crystallinity of this material is more important. And therefore, these equipment that we are yet to use for analysis are actually important in identifying the size, the shape of the nanoparticles and the nanorods that we are synthesizing in our laboratory. Also, the seminars and conferences are still pending. Publications and of course the final report are still pending with us, but we are hopeful and we are positive that in this next phase that we are entering now, we'll be able to complete the characterization and also complete the write-ups in terms of papers and also submission for publication. So for this, I know there's still a lot that we can talk about, but this is just a summary of our milestones so far. So I thank you all for listening. Asanteni sana.
Thank you so much, Sharon. Your work is really enlightening, especially to Data Science Africa, because it's new. And we're very grateful that we've been able to contribute to the lab that you've established at Murang'a University. on material sciences. I was curious about the data. Are you going to make the data that you have developed in the lab open access? Because I understand we are used to the normal themes on agriculture, health, languages, but material science is a new domain at DSA. Are you going to make the data available on open access? Yeah, Sharon, I think you're muted. Yes, Sharon?
Yes, then it will be accessible to everyone who would want to see what we are doing in our labs.
Okay. Do we have any questions from the audience? Thanks a lot for sharing your work, the good work you're doing at Murang'a University. Do we have any questions for Sharon from the rest of the participants? Yeah. Okay. Thank you so much, Sharon. Let's have Jennifer present next. Thank you very much, Sharon. Really appreciate it.
All the best.
Okay. Let's have Jennifer. She's going to present her work in French. If you could stop sharing, Sharon, so that Jennifer could load her PowerPoint. Thank you. Yeah. As Jennifer uploads her presentation, her work is on the contribution of machine learning and remote sensing for the improvement of groundwater quality assessment in the municipality of Zakota in southern Benin. Yeah. Okay, Jennifer, over to you.
Yes.
We can see your presentation. You can start, and we'll have Bonnie, who is going to moderate this session, this particular presentation that will be in French. Yes, Jennifer, you can start, please.
Thank you, dear. Chers organisateurs et invités, bonjour. Je réponds au nom de Jennifer Arolonso, étudiante en master d'eau d'hydrogéologie à l'Institut national de l'eau de l'Université d'Abomey-Calavi. Je suis là aujourd'hui pour vous présenter le rapport de nos travaux d'activité intitulé « Apport de l'apprentissage automatique et de la télédétection pour l'amélioration de l'évaluation de la qualité des eaux souterraines dans la commune de Zakota ». Ce projet a été financé par le prix de recherche en intelligence artificielle en Afrique. Notre présentation se déroulera comme suit. On aura d'abord une introduction, la présentation de la zone d'étude, les matériels et méthodes d'étude, les résultats et discussions, le travail récent et enfin la conclusion. D'après Maurice et Hall, les 95% de l'eau douce de la planète représentent les eaux souterraines. Captées à travers les puits et forages, ces eaux sont utilisées comme des eaux de consommation à cause de leur meilleure qualité. Mais force a été de constater aujourd'hui que ces eaux sont polluées. Et cette pollution est due d'après à l'ASTAN aux activités anthropiques. C'est le cas de Zakota, une commune de Zou, où se pratiquent de nombreuses activités, notamment l'agriculture, la pêche et autres. Il est alors important de trouver un moyen pour améliorer la qualité de ces eaux. L'objectif général de notre travail est d'évaluer l'impact de l'utilisation des terres sur la qualité physico-chimique des eaux souterraines de la commune de Zakota. Plus spécifiquement, on aura actualisé les connaissances sur la qualité physico-chimique des eaux souterraines de Zakota. Ensuite, fait l'analyse diachronique de 2008 à 2022 de l'occupation de sol de la dite commune. Et enfin, mettre en place un modèle de prédiction de la qualité des eaux de la dite commune. Comprise entre les coordonnées 2 degrés et 7 degrés, nos études se situent au Bénin. Une un pays de l'Afrique de l'Ouest comptant 12 départements et 77 communes. Zapota étant l'une des communes du département du Zou, elle est limitée au nord par la commune de Djidja, au sud par la commune de Zoukoudome, à l'est par la commune de Kové et à l'ouest par la commune de Boïkon. Couvrant une superficie de 409 km², elle compte une population de 166 224 habitants d'après les données de 2019. Les différentes activités menées sont la pêche, l'agriculture, la production animale, la production d'huile de palme, la transformation des produits vivriers. Sur le plan hydrogéologique, l'on y note 4 unités à savoir. Au nord-est, nous avons le sort recouvert généralement de gneiss. Au nord-ouest, nous avons le Bisocèle caractérisé par une très faible épaisseur des dépôts sédimentaires. Au sud, nous avons les formations sédimentaires composées généralement de sable, argile et marne. Et enfin, nous avons les dépôts alluviaux récents constitués de sable, argile avec gravier. Les différents matériels utilisés pour aboutir à notre travail sont un flacon en polyéthylène de 1,5 litres ayant servi au prélèvement des différents échantillons. Nous avons utilisé également un GPS permettant la vérification des différents sites à échantillonner. Nous avons également un multiparamètre pour la mesure des paramètres ainsi tout sur le terrain, un spectrophotomètre pour la lecture des absorbances au laboratoire, un chlorimètre pour la mesure du TTS et des métaux en suspension. La méthodologie utilisée est la suivante. Nous avons d'abord eu à faire des recherches documentaires dans les mémoires, thèses, articles de journal et autres qui ont rapport à nos thèmes. Ensuite, nous avons collecté les données physico-chimiques de 2008 à la DGO. Nous avons également échantillonné dans d'anciens forages et bassins pluie. La figure ici présente montre la carte d'échantillonnage de la zone d'étude. D'après cette figure en rouge, nous avons les forages et en noir, nous avons les puits. L'objectif était de prélever uniquement les forages, mais force a été de constater sur le terrain que la majorité des forages n'étaient plus fonctionnels. On a donc prélevé les puits situés à proximité de ces forages initialement choisis. Plusieurs analyses ont été faites. Sur le terrain, nous avons mesuré la température, le pH, la conductivité électrique et l'oxygène dissous. Au laboratoire, nous avons mesuré le TTS, les métaux en suspension, le chlorure, les sulfates, calcium, magnésium, carbonate, bicarbonate, fluorure, sodium, nitrate, nitrite, manganèse, sodium, orthophosphate, potassium, fer total et le CO2 libre. Pour l'analyse diachronique de l'occupation du sol, nous avons d'abord en un premier temps téléchargé les images satellitaires Landsat de 2008, 2013, 2018 et 2022 sur le site USGS. Nous avons ensuite traité ces différentes images à l'aide du logiciel QGIS. Le traitement a été fait en 3 étapes. Nous avons d'abord la phase du pré-traitement qui a consisté au paramétrage du logiciel. Ensuite, nous avons la phase du traitement qui a consisté à l'identification des différentes unités d'occupation du sol et ensuite à la classification de l'image. Nous avons enfin la phase post-traitement qui a consisté à la validation de la classification et la mise en page des gaz. Notons ici que la validation de la classification a été faite sur le terrain. Nous avons pris sur le terrain les coordonnées de quelques unités d'occupation du sol que nous avons projetées sur les cadres réalisés afin de voir si les cadres réalisés reflètent réellement les réalités du terrain. Les différents résultats obtenus au cours de nos recherches sont les suivants. Les 2 tableaux ici présents nous montrent l'évolution temporelle de la qualité des eaux souterraines de la commune de Zapota. À gauche, nous avons les données de 2022 et à droite, nous avons les données de 2022. D'après ces 2 données, l'on constate au cours de ces dernières années que les pH ont varié généralement entre 5,89 et 6,57 et la conductivité de 135,77 à 228,80. D'après ces résultats, l'on peut conclure que ces eaux ont un caractère acide avec une minéralisation moyenne. Notons également une augmentation des concentrations en nitrate, phosphore et fluorure au cours de ces 2 dernières années. Ces résultats sont conformes aux résultats de Torsou et Hall, à Rolonceau et à Zokota, qui affirment que les eaux de cette zone contiennent des traces de nitrate, fluorure et phosphate. La figure ci-dessous nous présente les diagrammes de Pepper réalisés pour les données de 2008 et de 2022. D'après ces deux diagrammes, l'on constate que les eaux de cette zone ont généralement un faciès chloruré magnésienne. La figure présente ici dessous nous présente les différents cas d'occupation du sol réalisés. D'après ces quatre, on a généralement 4 unités d'occupation du sol, à savoir la végétation, les cultures jachères, les formations marécageuses et enfin les agglomérations. La figure ci-dessous nous présente l'évolution des superficies des unités d'occupation du sol au cours des années 2008 et 2022. D'après cette figure, l'on constate qu'il y a eu respectivement une régression de 10% et de 25% de la végétation et des formations marécageuses au profit des aires d'agglomération et de cultures et jachères. Notons également que nous avons constaté sur le terrain l'utilisation des herbicides et pesticides pour l'augmentation du rendement agricole. Ainsi donc, de ces deux constats, l'on peut dire que l'augmentation des concentrations au cours de ces dernières années en nitrate, phosphore et fluorure serait due alors à l'utilisation de ces herbicides et pesticides. Nos résultats sont alors conformes aux résultats de Aziz, qui affirme que la pollution des eaux provient généralement des déchets domestiques et principalement du lessivage des engrais et un fluent d'élevage dans les zones agricoles. Nous sommes ici à l'étape de modélisation. Ici, nous avons choisi le modèle, d'utiliser le modèle des réseaux de l'euro, car c'est un modèle qui a comme pour entrer qui prend comme entrée plusieurs couches et qui a une seule sortie. Ce modèle est alors bon pour notre travail. Les différentes données à utiliser sont les données physico-chimiques et les valeurs d'unité d'occupation du sol. Notons que nous avons eu à effectuer en août dernier un échantillonnage pour vérifier les données, pour comparer aux données de 2022. D'après tout ce qui précède, l'on constate que la culture intensive et l'utilisation des temps agricoles et pesticides pour la production agricole par les populations ont entraîné une augmentation temporaire des concentrations des minéraux en nitrate, phosphate et fluorure. La détérioration de la qualité physico-chimique des eaux souterraines des Zapotas est due alors aux activités anthropiques. Le modèle de prédiction en cours d'élaboration servira dans la prise de décision en vue d'une meilleure gestion des eaux souterraines. Chers organisateurs et invités, nous voici à la fin de notre présentation. Vos questions et approches sont les bienvenues pour améliorer la qualité parfaite de notre travail.
Merci, Jennifer. Thank you so much for the great presentation. Yeah, let's have Bonnie to to ask the questions. And if you have any questions, please ask, and then Bonnie will definitely translate to Jennifer in French. Please feel free to ask. Yeah.
Well, thank you, Dr. Dina. Jennifer. Jennifer, do you hear me?
Yes.
Bon, maintenant je vais parler en français. Eh bien, merci beaucoup pour la belle présentation. Et ça me fait longtemps que je n'ai pas parlé en français, mais je vais essayer de diriger bien les cours. Bon, est-ce que tu peux nous dire que vous allez rendre les données disponibles au libre access?
Oui.
OK. Et puis, jusqu'à maintenant, je n'ai pas vu l'apprentissage automatique. Comment ça va marcher? Parce que vous avez parlé beaucoup de comment vous allez collecter les données et tout ça. Mais je n'ai pas bien vu des apprentissages automatiques.
Oui, la modélisation est en cours. Nous avons effectué le mois passé un échantillonnage pour comparer ces données, les données de 2022 et les données de 2023. Donc, le traitement de ces données sont en cours. Nous avons eu récemment les résultats d'analyse, ce qui a un peu traîné les travaux.
OK, d'accord. Et quels sont les déficits rencontrés jusqu'à présent?
Les déficits rencontrés.
Oui.
If you can share with us, Bonnie, what you asked her.
Well, I've just asked her if they are going to share the data on the open access. She said yes. But also I've tried to ask her because until now, I didn't see much of the machine learning. So I tried to ask her what exactly, because the machine learning is not clear yet. And she have told me that right now they were just collecting the data, and maybe the next stage it will be for machine learning. And then the last question was what are the difficulties up to now? And the last question, the difficulty that they've faced up to now, she was trying to respond, and she have not responded yet.
Okay. Yeah, thanks. Actually, I had a question on slide 10. I wanted to understand what did they use the QGIS software for on slide 10?
QGIS, OK. Bon, Jennifer.
Yeah, it's indicated.
Jennifer, est-ce que tu peux nous passer aux page 10? Jennifer, tu es avec nous? Oui, page 10. Bon, il y en a quelqu'un qui voulait demander comment vous avez utilisé le QGIS.
Dans le logiciel QGIS 3. Il y a un plugin appelé SCP, semi-automatique.
SEP.
Oui.
Et automatique.
Oui.
Well, Dr. What she's saying that they've just applied, there is a software called SEP, which is automatic to capture the details.
Of the images, the remote sensing images.
Yes.
Okay. Yeah. Thank you. Thank you very much. Thank you very much, Bonnie, and thank you very much, Jennifer. Yeah. Next, we'll have Sandy.
Hello?
Yeah, thank you so much, Jennifer. If we're going to have next Sunday, going to present his work on developing Yoruba and Pidgin speech database for health. Okay, yeah. You're welcome, Sunday.
Good afternoon.
Afternoon, yeah.
Please.
Okay, you're welcome. If you could have your in full screen, yes. Okay.
Can you see my screen?
It's still, yeah, we can see your screen. It's not on full screen mode yet.
Okay. Yeah. I think it's on full screen now.
Okay, great. Please
Yeah.
go over, take it over.
Yeah. Good afternoon, everyone. My name is Sunday Adeola Jagbe from Computer Engineering Department, Ladoke Akintola University of Technology, Ogbomoso, Nigeria. One of the awardees of DSA DLI 2022 award. The topic of my work is development of Yoruba and Pidgin speech data sets for antenatal orientation. Of course, is in healthcare domain. The outline of my presentation are the introduction, the review of related works, methodology, results, and discussion, as well as conclusion and future direction, future consideration of the research. As we all know, language is a crucial component of human lives and a fundamental aspect of human behavior. According to Koshel 2017, the language is expressed in two forms, majorly, because we also have a body language, which is just gesture and other related means of communication, which also have their own meaning. But basically, we have language being expressed in spoken and as well as in written, and it is used for decision making and expression of feelings, which translates to a kind of reaction. It's an aspect of natural language processing, which is one of the core areas of research in artificial intelligence today. The major application of natural language processing are spoken dialogue system, speech recognition, speech synthesis, text summarization, information extraction, automatic summarization, as well as machine translations. All of them are depicted with figures that characterize their names and their operation or applications. One of the big questions confronting human beings in this era of computer communication and manner as which human beings are communicating presently is that can human being communicate with a computer through a native language? And the answer is no. This leads to the challenge in developing natural language processing application, which computer need structured data sets, but human speech are unstructured and ambiguous for computer to understand. However, the absence of quality data sets and absence of high quality annotated and speech data sets are a big concern that give a computer a big problem here. So considering the healthcare domain, which I'm presently looking at, scarcity of healthcare data sets in African languages is one of the limiting factors for artificial intelligence, natural language processing, and ICT-based solution for in the continent. Looking at the figure, the medical experts consulting with the patients, and the patient could not actually understand what the medical expert is saying because the expert is not talking in the language that the patient understands. Of course, you agree with me that at the end of the day, whatever diagnosis or treatment that such a medical expert is prescribing may not be able to meet the desired objectives. And that informs the aim of these projects, which is develop Yoruba and Pidgin data set resources for antenatal orientation. And my objective I have the acquisition is to acquire or extract antenatal orientation guide in English language in line with WHO document of 2016 that actually work in this direction, and translate this guide into Yoruba and Pidgin text. I'll also go on and to implement the speech version of the English and of the Yoruba and Pidgin antenatal orientation guide. And finally, to calibrate a deep learning based feature extraction using speech data sets created in Objective 3. Going through the literature, I have numbers of literature that are conducted in this regard. In reference 6, the data set used for their work was a religion data set, which is none of them an African language data set. Over 1,000 language was filled according to the researcher, and none of the language focused in health domain. But they are also speech data sets. So the reference 7 talks about the use uncategorized data sets, which is in Métis and English. And the data set was not focusing on healthcare solutions. Reference 8 and reference 9, both of them also work in the same direction that were not specified the area that's the domain where they are working. The English and Yoruba was considered, and it wasn't in healthcare domain. And reference 9 was not in healthcare domain, and an African language data set. Reference 10 talks work in healthcare domain. French, English, Portuguese, and Spanish were used, and you can agree with me that the data sets used in this implementation, their own implementation, none of them was in African continent. Reference 13 was use an isiZulu and English data set. It was in political domain, whereby the parliamentarian and data sets were used in South Africa. Hello?
Yeah, we can hear you, please.
Oh,
Sorry
okay.
for the interruption. Sandy.
Okay.
Continue.
Okay. So the parliamentarian data set that was used in the implementation, which is an isiZulu and English, was a political or the governance set of data sets that has no synonyms with healthcare applications. So reference 14 used a religion data set, which was did an English and Igala translation. It was not in healthcare domain. Igala is one of the languages in Nigeria. So it's one of the languages in the Middle Belt in Nigeria. So reference 15 is use a daily newspaper, Holy Bible, hymnals, and motivational book for translation. And it was in text, and it was only translation on English and Yoruba. It wasn't in healthcare domain. Reference 16 was in healthcare domain. This paper was the collected baby cry of Netherlands, baby less than 6 years old, 6 months old, and they got over hundreds of Netherlands babies that are crying. So the data set was a speech data set, a set of speech data set that, of course, also comprises of other informations like when a baby is crying, the mother was petting, and maybe another person is opening door and the rest like that. So that necessitated a kind of further research to extract the baby cry from the other interactions or other things that are not involved in the baby cry in the data set. So the work, they use a deep learning algorithm to do the extraction. So reference 617 was not categorized in any domain, whether health or political or religion, but a native data set, which is not an African data set, was used in their study. This is to show that African continent, there is a need to populate the African data set, especially in healthcare sector, containing overtone and practice measures that have been taken to promote the African languages over the year, but none of these measures have been dedicated to focus on the healthcare domain, even looking at the importance of the healthcare to human assistance research methodology. This research was set up after the award was, after we received the grant award. So we set off by contacting a tertiary healthcare center, which is Ladoke Akintola University Teaching Hospital in Ogbomoso, Nigeria. So, and another set of proposal has to be written to the university management to secure the ethical approval for this project, which was granted after some months. So the data set was collected and annotated in text. It was translated, and we have this to the Yoruba and Pidgin version. Then we have the speech version of them recorded. And of course, we have the editing and we have the evaluation and the testing, which shows the framework of the data set for the antenatal orientation. This is part of the days where we are at the hospital meeting with the nurses and the language experts that also accompany the project. So data set and why. We have the English data sets of this project, we have the Yoruba, and we have the Pidgin, making it multilingual data set. It's beyond the bilingual. So the English languages is often is known to everyone. The Yoruba language is spoken in West Africa, primarily Southwest and Central Nigeria. It is by the ethnic called Yoruba people, spoken by the ethnic called Yoruba people. Pidgin is a language that is grammatically simplified for communication method, usually developed when two or more groups have to develop a system of communication when a common language doesn't exist. So we also have Swahili, Zulu, and others, Swahili Pidgin and other Pidgin, but this one that we are working on is English Pidgin, not Swahili or any other Pidgin. The data set was contained the pregnancy. The data set for the study contains of the pregnancy developmental stages, the challenges that the pregnant women should expect during their pregnancy stage, the precaution to be taken, type of food to be eaten, etc. Why are we looking at this area? Nigeria constitutes 2.4 world population and currently contributes 10% of the global deaths for pregnant women, according to the World Health Organization report in 2021. So this posed a challenge to people in Nigeria because looking at how we can attain MDG in this regard. So this is one of the days where we were in the antenatal clinic. So this is part of the experience in the antenatal clinic, where the women has to do preliminary exercises before they will be attended to by the nurses and the doctor. They are there to do a lot of precaution and preliminary exercises before the healthcare attendants will begin to attend to each of them. So after we started the work, 6 different antenatal clinics were recorded using 8 gig Sony digital voice recording immediate system, alongside with the language expert. Language expert was involved even during the orientation attendance, because of some of the terms that is being used by the nurses are not familiar with the annotations and the language contents that are popular. However, it is accepted because of the locals, I mean, people from the rural areas in the area that the data sets were collected, because the local area, the villages were surrounding, the villages surround Ogbomoso, and people come around from the local area to ensure that they are getting quality healthcare for their well-being, and especially for their babies. Each clinic was about 1 hour orientation that always precedes the healthcare attendance. Now, during the data set annotation, we use a special Yoruba keyboard according to Odejobi et al. 2011. This data set, I mean, this keyboard, when we get to the data set, you will see that there are some syntax, there are some alphabets that is not recognized by our conventional or our popular computer, but were recognized by this special keyboard. So that's one of the reasons why this was employed for the annotation of the text version, especially for Yoruba. So the speech version was implemented in a simplified frequency recording of FX 41,000 Hz and B24 28.16 bits. Mode of saving was MP3, and it was recorded in stereo. So we went further to look at the fourth, the approach we employ for the fourth objective, that is to calibrate a deep learning speech analysis of the data set recorded in 3. So we have the host code of the Linux machine with 17 CPU and memory of 10.2 gigabytes and a disk of 170.3 gigabytes. So the implementation was done using TensorFlow, Jupyter Notebook, Keras, because of their high possibility and high data annotation and manipulation of the data sets. And Keras was used also for the analysis. MFCC which is widely used for speech and audio analysis, was involved for the analysis of the audio version, and also for the speech was divided into a speech signal for proper analysis. Now, these are the result of the implementation. In one, we have the English version. In first, okay, we have the serial number, we have the English, and we have the Yoruba, and we have the Pidgin in fourth column. So for a pregnant woman that is just pregnant, newly saying one of the information we had was that the pregnancy flu, the period, the monthly period will stop. So in Yoruba, they will say in kausu, niwa, uniwa, in kausu uniwa, and Pidgin will say the period will stop. So you see that here in Yoruba, for instance, now we see that we have some diacritic signs that make even the text not to be recognized by the normal conventional computer, and even any IT-based application that you are developing. We have effects based on this because the IT-based application that was trained or that was developed was not trained using this data set as a result of not being available. We also have some other examples of how this was orchestrated using special Yoruba language keyboard, so which the texts are available, and we evaluated looking at the numbers of word counts and the speech time, and as well as we place them side by side. So where we have Yoruba language, which is on the high side in terms of numbers of word count and the type for the speech. And of course, this will definitely result into a kind of a computational complexity, which might have not been considered before. But this research is bringing on board for investigation and further research. So we have the three versions of the speech being developed too. So I have
we can't hear the audio.
Sorry for that, Mr. We have the initial one was English. This is Yoruba version, and so these are the three languages that were voiced together, that were voiced separately for the analysis. So in calibration of deep learning analysis of this speech, so we come up with analysis of the three data sets that were developed. So we have an implication where the MFCC coefficient was considered as a metrics as against time for the three languages. So and then we further analyze the speech, and we realized that the computational complexity, like I said, resulted. Looking at this graph, you look at it that the white portion represents the undertone that was caused by as a result of the computational complexity of Yoruba language. You see that this white portion are so many when it comes to when we plot the line graph for the Yoruba, and the one for the English version is minimal. Likewise, the one for the English Pidgin are minimal. But when it comes to Yoruba version, so it is minimal. So when you subject any data set of Yoruba to the same environment, whereby the technology you are developing is trained by this type of English version, it will definitely result into poor delivery because we have not taken into consideration the native and the characteristics of Yoruba language into consideration. So, in conclusion, over 2,000 different languages is spoken in Africa, in the African continent, which has a diverse, very diverse language population. However, most of the speech recognition and AI-based systems are being trained on trained on data sets that give priority to the most popular languages, as we have seen in the literature review, which are English, German, and Spanish, and the rest like that. Not looking at the languages from Kenya, or not looking at the language from Nigeria or South Africa. So definitely such a technology will not address the expected problem that you are trying to address. So now this data set is going to solve this part of limitation. And in our future consideration, we are looking forward to see how to develop a mobile hub for antenatal orientation, whereby the people that doesn't understand Yoruba, that doesn't understand English, can download their mobile hub and listen to it and take necessary precaution, and thereby reduce the minimize the deaths of the pregnant women in the continent, especially in Nigeria, starting from Nigeria. We are also looking forward to design and develop an algorithm for text summarization using this native data set. Then the Pidgin data set for deep learning code switching, because it has the mixture of English language and other language that are not recognized by English. So these are other focus of the study. And we are also looking forward to develop a deep learning based model for speech to text and text to speech system using African native data sets. The deliverables are last publication of this work. So we are hoping to publish the multilingual text data set, which comprises of English and English, Yoruba, and Pidgin, as well as the speech data set, which is being produced by this work in a reputable repository. Recently, we have submitted a paper titled Developing Multilingual Speech Data Resources for Nigerian languages for antenatal orientation, which is currently under review in South African Journal of Computer, in South African Journal of Science. So these are part of my references. Thank you for listening.
Hey, yeah, thank you very much, Sunday, for sharing with us your work. My question is, how big is the data set? I understand it's audio. How big is it?
After we did, we initially recorded the voice for 6 different times. So we now try to familiarize the data set with what is contained in the World Health Organization recommendation for the guide of antenatal care. So we have, the data set was about I think it was about 14 gig. About 14 gig. Yes.
And how many hours in terms of time or minutes of recording are there?
The one we recorded, the one we recorded was about 6 different hours. Some days were not up to an hour, but after we now did our editing and put in some necessary information, so we have 1 hour 30 something minutes for English. Different hours were recorded for the 3 languages. It's not, it wasn't the same. It wasn't the same.
Okay.
Yes.
All right. Okay, thanks. And what kind of models do you plan to develop using the data set?
Say it again.
What kind of machine learning models do you plan to develop using the this data set? Yeah.
Actually, we have in mind of using deep learning, and particularly looking forward to see to implement using convolutional neural network, and possibly look at what's a recurrent neural network, and look at LSTM. While I got this grant last year, I was still doing my Master of Philosophy in Computer Engineering. So now I'm done with that. I'm currently a PhD student in the same department, that same university. So I'm hoping to use this data set, experimenting 4 different deep learning architecture, which is CNN, LSTM, RNN, and multi-layer perceptron. And when I look at the performances, and especially the area of Yoruba language, which is having a lot of issues, so I may work towards using some power-inspired optimization to see if there is going to be an improvement, which I definitely believe there will be an improvement, and come up with a philosophy that people can also try to improve on.
Okay, thank you very much. One last question. Did you factor during the pre-processing work, did you factor out the data set, especially the noise removal? We have this question. Did you consider noise removal when you are pre-processing the data?
We consider noise removal, but actually the calibration we did was actually to detect the level of noise in the 3 data sets. We are not even looking at the noise removal yet, but we only want to see the level of noise contained in each of the data sets, and which we realize that the noise in Yoruba language is higher compared to English language and the Pidgin English.
Okay. Yeah, and you check on the chat, there's a comment, advice you're given about what you need to consider. You may consider hybridization or optimization of those algorithms for possible or better performance. That's a good comment from Dr. Hallelujah. Yeah, it's there on the chat. Thank you very much, Sunday, for the good presentation and sharing your work. Our next presenter is Mercy Mawia. We're going to have a talk from Mercy. She's going to talk to us. She's from JQuat, and she's going to talk about explainable ML approach on sensor-based human gait analysis for assistive device model prediction and 3D design. Yeah, you're welcome, Mercy.
Thank you. I don't know whether we can be able to see my screen.
Yes, we can see it. Yeah.
Thank you.
Over to you.
All right. Okay, so my name is Mercy Mawia Mulwa. I'm a student in Jomo Kenyatta University of Science and Technology, and I'm thankful to data science for the funding that I'm receiving. So my topic is explainable machine learning approach on sensor-based human gait analysis for assistive device model prediction, 3D design. So I am a PhD student in IT at Jomo Kenyatta, and I'm also lecturing at an institution here in Nairobi called Mohammed Education. I was awarded the junior research grant from DSA, and also I'm currently a fellow also at Mawazo Institute. So a small background of what we are doing, human gait analysis is really crucial in the aspects of sports, even health diagnostic, orthopedics, and all that. So because of that, there has been a lot of emerging technologies that are sensor-based, that are cheaper, that they can be able to capture information about the human gait. Because through this, you can be able to diagnose diseases and also try to see if there is any problem with our motion or locomotion and all that. So machine learning models have also been used to enhance the disease diagnosis, also prediction. And because of that, they have been applied. Recently, they have been applied in human gait analysis for accuracy. However, even though they are being, like people are proposing to apply them, but clinicians or the people in the medical field are still finding it so difficult to make use of these machine learning models because of their opaqueness, somehow not easy to interpret because they are not transparent, and the people cannot understand clearly why the model is doing or recommending the way it is recommending or predicting the way it is predicting. So because of that issue of explainability, there has been a hindrance in the medical field. So there has been now research towards explainable machine learning or the artificial intelligence that helps to deal with that issue of transparency, machine learning. So these models or the XAI, the explainable machine learning models, are categorized into model agnostics. There are those which are local, there are those which are global, futuristic, post hoc, among others. But in our case, model agnostic approaches based on research found out that they are somehow effective any machine learning model. And among these model agnostic approaches have the line and the sharp, which are commonly used. They're suitable for different data types. So line one, which is an approach that is built on a sparse linear model. So it is fast in prediction or in explanation. Also, it is a bit easier compared to the sharp, which is requires a lot of requires a lot of computation. So our objective for this research was one, to check classification and clustering techniques and find out what is more effective for assistive device prediction, human gait, then use that most effective one, develop a machine learning model that can be used for device model based on human gait. Also to do the DCM to compare the appropriateness of DCM approach that would be used for the 3D reconstruction of the assistive device. I've not yet done that, but now we are in the process of finalizing. Then we were also to evaluate the performance of the development models, also to implement the optimized line, that is the explainable model we opted to use so that you can see the performance compared with the original model. So we did some studies, we did some research on the human gait applied machine learning, or the machine learning methods or models applied in human gait analysis. Quite a number of studies came out. What was coming out is that several studies, most of these studies are classification based. So we not pick so many of the clustering aspects, but we can see how these machine learning models, the classification based machine learning models, were behaving on human gait, the accuracies. So most of them, the ones we picked here, are doing so well in the machine learning. But even though classification is important, clustering is also important because it will help us to pick out or to group these people, the cases, which maybe where the data is not labeled. So somehow, even as we do the comparison, yes, most of the research is inclined towards the classification of human gait, but we also need to at how clustering could be applied. So our research majorly focuses on the LIME explainer model, and it is really efficient compared to the SHA in terms of computationally effective, an alternative to SHA. It is a model agnostic model or algorithm. So what it does, it tries to explain a black box model, or the machine learning model we are trying to integrate. It tries to explain it within a local vicinity. So it tries to check the complexity of that model within the location where the data set or the item we are trying to explain is located. So uses the proximity measure, that is this proximity measure here, to check the local neighborhood of a particular data set. Then using that neighborhood, it tries to generate some data. It tries to generate some data, random data here, and through this random data now, it will do an interpretation of the machine learning model within that particular data which has generated. And from there, we can see to the outside, or we can see from the small portion of the data how the machine learning model is operated through this stage of interpretable representation. So through the LIME, we can be able to see how the model, the machine learning model we are using, is behaving in a local vicinity or in a local place where a particular data set or a particular data item or an instance is located. So the main challenge with LIME, even though it can explain very easily and it's very simple, that during this stage of data perturbation, or when it is doing the random, because it tries to generate some synthetic data using Gaussian sampling, what you call the normal, the technique of using the mean standard deviation. So during that stage, it will generate some data. But now, because of this random generation of data, we find that there is a bit of stability in the results. So if we try to run this test instance, for example, 3 times, then because of this random data computation stage, there will be different, like it will generate different results every different time. So because of that, it is we need to improve so that it can reduce this instability. It's one thing we are proposing to do in this study. Then the other issue about LIME is that it is designed to specifically deal with classification and regression algorithms. So it cannot handle the clustering algorithm as it is, not unless we adopt, or we do an adoption, or we create an adoptive LIME that can be able to deal with the clustering data, because it is also important for us to explain why is data being clustered in this particular cluster, what are the main reasons, which features are important for us to cluster data in a particular. So those are the 2 limitations we were trying to work on during this study. So what we supposed to do, the variations, the research was all about is, 1, to try and deal with the random permutation or perturbation data by introducing GMM perturbated. So we're trying to bring in the GMM algorithm so that we can be able to deal with this aspect of random data, because GMM is a probabilistic framework. So it is easier because when we do the clustering using GMM, we can be able to see the underlying data structures within the data. Then through that particular structure, we can be able to create we can now generate data which is closer to the structures that are existing. So that is what we're trying to do so that we can improve or reduce this randomness during the creation of this random data, because the random data is important because we want to see how the model will behave within a local place that is closer to the instance we are trying to predict. So the other thing we tried to do was to come up with a LIME-based clustering explainer that could be used to explain the clustering. So the data sets we used for our study were two. So the first data set is the UGADB, and the other one is the Gateway data sets. So these ones are existing as of now. We have worked on existing data sets to train the model and see whether it is working. But in the future, currently we are working on our own data set that maybe would be available once we are done working on it, to see whether now, whatever we have done, whether it can also work in primary data sets. So we created the two algorithms. So the first algorithm here is the GMM modification, what we propose to change. It is just the part of editing, the part of getting the data, the perturbation. This is where we are using sampling so that we can be able to generate the clusters, and then through the clusters we can sample around where the data item is located. And then we also did another algorithm for the clustering model. So this was just based on what we have currently in LIME, trying to now customize it and see whether it can be used for explanation. So for the machine learning model we used on the data sets was the MLP, because it is unique, especially when you look at the table, it performed very well. So because of that performance and being a neural network, then we could be able to explain our data using the MLP. And these are the results of the MLP when performed on the data set. So on the Gateway, the data set, Gateway, MLP had an accuracy of 92%. So UGADB, it had an accuracy of 0.9, and that is 99%. So it performed very well, and we can also see the confusion matrix here, explaining how the performance was done. So using the UGADB, because of its performance, we were able to go a step further and try to do the interpretation of the study, or the interpretation of the results based on the explainable model, the original line, and also the model we created. So this is also just an explanation of how it performed in terms of the ROC on both the Gateway and also the UGADB. This is what we're doing. So on this side here is the explanation of our data set, the explanation of our explainer when done on the UGADB data set. So it explains to you which features, after you run the MLP, then which features are positively affecting the results and which features are on the negative side. You can see as presented here. So what we did, we tried it in 10 cycles so that we see the instability bit, because we are saying when you try it several times, then it is unstable, or it produces unstable results. So on this side here is our model, and on this side here is the line. So when we tried to run it, for us to see how different these results are, we had to run another test so that we can be able to compare the performance of the two models. But these are the features that stood out for each and every cycle of our testing. So again, we also represented it using a bar graph, and these are the features. So still the same cycles. So this side is the GMM modified, and this side is the line explanation. So you can see there are some slight differences from one cycle to the other because it's still work on progress, trying to optimize it or improve it so that we can gain as much stability as possible. So what we were able to do to compare the two models using the UGADB, we did two things. Compared it using MSE, that is the standard error, and we also compared it using the Jaccard similarity. So if you check the two results, using the MME line, you can see the standard error is lower compared to the MSE. The error is a bit higher when you compare the two models. So which means in the UGADB, this one, in terms of the standard error, GMM performed better compared to the original line. So this, we tried to compile the 10 cycles, and then we did the average of the error that we are getting, and that is the error we are getting. Now, when we did the comparison of the same using the Jaccard similarity value, so the work of similarity value is to show how close the result is to the truth. We could see the Jaccard similarity for GMM is at 0.4, while this is 0.41, while this other one is at 0.39. So still better, but not as much as we would wish to attain at the end of it all. So still, we need to see how else we can do to improve the Jaccard so that we can increase it to a bigger value. But so far, we are still getting some better results compared to the original line. So we did the comparison for the two data sets, the UGADB and the GateRes, and we could see that still continuously the GMM was performing a bit better compared to original line. So we now went further to get using our explainer to try and do some prediction of a device. So we also attained a data set online that contains the features or the devices that people with the disability of the foot would put on. So the data set is a bit small. We are trying also to see how we can improve it so that we can get a bigger data set. So we try to use it to see how this prediction model is operating. And through the prediction probabilities, the device which was picked was this, the device which is as 1.0. And this is the reason why it was picked based on the features you can see here. And then from there, using prediction, the NLP would predict the device. And because the device is connected to the devices are connected to the pictures in the data set, then the picture was also displayed or was generated as output. So that is basically what we have been able to do. We still have some work to do, especially on the area of 3D design, because the data sets we are using or we are getting are not really complete, especially for the reconstruction, because we are looking forward to reconstruct a 3D model using the existing models and then also using some data. So I've currently engaging a few people who could help us in structuring these data sets so that you can be able to see how we can come up with a 3D model that will help us achieve the 3D design. So that is the objective, which has not completed, but we are looking forward. So that's my work.
Yeah, thank you very much, Mercy. It's really well detailed and especially covering the explainable, how do you conduct explainable ML? So that, which is very, very a pertinent and very active area that we really need to be able to explain these models. We have a question on the chat from Dr. Hallelujah. He is asking about what social good will the implementation of this model be? Which area of application can your work be applied to?
So it could be applied in several places, especially in the medical field. So I'm looking at a scenario where somebody will go to the hospital, they have a challenge, maybe they are not, they need an assistive device, so they are not okay in a particular part of their body. And then through the sensor devices, we could be able to predict where their problem is. And because now there is the explainability bit, then the doctors can be able to clearly explain why you are suffering from this, what is the reason, which are the features that are causing what you're going through. And then from there, this model, at the end of it all, because we are planning to connect it to the 3D design, then it could automatically get your features and then generate the device, which if connected to 3D printer, when we get to that technology, maybe here in Kenya, then we could be able to print automatically without waste of time, and also being able to explain anything, everything you're doing.
Okay, thank you so much. And so you really find it being a cost-effective method for 3D.
Yes.
Okay. Thank you so much. And we have another question on the chat on feature selection. Did the study consider different approaches of feature selection, and which one worked well?
So for the feature selection, I did not do any change on how the LIME operates. The method it used to pick the features, I did not change. So not unless I go and adjust again and try to change so that I can see what works. So it's something I can explore even as I study.
Thank you so much, Mercy. And I thank everyone for sharing their work with us. And this really marks the end of the seminar today. I really thank all the presenters. We had 4 today, Dr. Sharon, we had Jennifer, Sunday, and Mercy. They've shared their ongoing work with us through their presentation. The presentations and all these, as we said earlier, they've been awarded through the Africa AI Research Grant. So we are very grateful for all the presenters sharing their progress. It's all work in progress and all the contributions. And majority of them are going to share their work on open source, their data set, and we will, as DSA and Deep Learning Indaba, we will definitely amplify the outputs of their work once they are done. We have another series next week, so we really welcome you all.